Hey, my name is Richard Young. I work at this very cool place called the Food Service Technology Center. And at the Food Service Technology Center, we study all the ways that commercial food service uses energy and water. We are celebrating our 35th anniversary as a research and training facility, and I've been there 34 years and have really enjoyed every moment of it. It's a pretty amazing place. And one important thing to know, because our subject matter today is decarbonization, is that we are a mission-driven, fuel-agnostic organization. Our mission is cutting carbon and saving water. So I don't care if you use gas, electricity, or unicorn tears, as long as the technology that you are using is cutting carbon, then everything is great by me. That's what we want to do. And my real purpose today, my goal, like the mission of today, I'm trying to give away millions of dollars and decades of experience with no strings attached. So who's in, right? Who's going to join on that one? Really, I want to say this right off the bat. I'm not a vendor. I'm not here to sell anything. I'm here supported with publicly funded energy efficiency dollars. So my job is to really give back information and knowledge that has been paid for by the public. It's a real win-win situation and a great job. So one of my questions I want to ask everybody, think about this. What are your energy efficiency, carbon reduction, water savings, or kitchen electrification goals? If nobody's given you those goals already, keep your head up, because you are going to get those. Somebody's going to come back to you. Certainly in California, the big utilities all have goals along these lines. And for a lot of people in the higher education world, the notion of commercial kitchens is something that's a little bit foreign to them. In fact, I would bet that most people in the higher education realm don't realize that your commercial kitchens, those big kitchens in your dining facilities, they're using 5 to 10 times more energy per square foot than all your classroom space. So if you're looking at a place to attack carbon and to save energy, certainly your commercial kitchens are a massive target. That's something you really want to go after. And when we start thinking about the big picture drivers of kitchen change, the things that are going on within your dining services that you also need to be aware of. Certainly the menu diversity and farm to table is a big one. We need more diverse kitchens where we can produce a lot of food in a lot of different ways. We're also looking at waste reduction and reusables. These are things where we need to cut the amount of food that we throw away, that pre-consumer food, and also we need to cut down on just the disposables that we're all pitching in the garbage can. So that means dish machines, plateware, all of this kind of good stuff. And certainly labor and space. We need to do more in less space, and everybody across the world in the food service industry, institutional or commercial, they all are having labor challenges. And we've talked about that. I've heard people mention that several times. And the final thing is, of course, decarbonization, electrification. How are we going to go about this? Will your food service organizations accept this? Can it be done? So I'll talk a little bit about this today and give you some resources. That's what I really want to do, give you some tools to move forward with all this kind of stuff. And big picture, what we need to do, the change that we need to make, is that we need to move from this traditional cook line, which is designed very much along the lines of 1960s kitchen design, and we need to move to our kitchen of the future, which is faster, smaller, and much more flexible. That fast, small, flexible helps us beat a lot of those issues that we were talking about before. So, and in that faster, smaller, more flexible kitchen, of course, we're using more programmable equipment, and we can get more done with less people. Now, if you're going to do this fast, small, flexible kitchen, and we're going to move towards electrification, and we're going to move towards decarbonization, then we need to think about holistic design in your kitchens. It's not just a matter of replacing existing equipment. First, you want to analyze the cook line and replace your old traditional energy guzzling equipment with smart high-tech equipment, which includes things like combination ovens and rapid cook ovens. And then you want to move to some of the, move a little wider, look at your existing equipment, look at things like high efficiency cooking, holding, refrigeration, sanitation. Across the board, energy efficiency is your very first step on that cook line. And then we look at some of the some of the future stuff, things that we need to move into our kitchens that aren't necessarily there now, which includes induction cooking and holding, which is a really amazing technology that works beautifully, and it's a game-changing technology. So that's our cook line. Now we need to step back and start thinking about how we use energy. Some of your campuses have PV. You have energy goals. So now we need to step back and think about how do we spread this demand across a diverse amount of time, and how do we spread our labor out? So now you need to start thinking about off-peak production. Can we cook in the nighttime? Can we use automation to cook things overnight? Can we run our staff 24 hours a day? So that's things like automation, cook, chill, sous vide. You've probably heard of some of these forms of cooking. And then the next thing we need to do is look at your kitchen ventilation, because every kitchen has a great big exhaust hood in it. So in order to save energy and make that kitchen both more comfortable and much more energy effective, you need to have a demand-controlled kitchen ventilation system in there. And what the DCKV system does is it adjusts the volume of airflow in your kitchen based on how much cooking is going on the cook line. So a really, really good technology. We've tried it out in multiple installations across the spectrum, and typically it's cutting energy use right in half. Then the next thing that you need to look at, which is really, really important because your all-electric kitchens, many of those are going to include heat pump water heaters as the highly efficient technology that's going to lead towards the all-electric kitchen. But you cannot use heat pump water heaters in a commercial kitchen unless you do some advanced plumbing design. Heat pump water heater will fail in many, many situations if you don't do it right. Then the next thing is to look at your optimized HVAC as well. And both of these things are the heat pump water heaters, the heat pump space heating are mechanical engineering challenges, and you need to work with your MEPs as well as your food service designers to make all of this stuff go. Now, some benefits of high efficiency equipment. Performance. Efficient equipment produces more food. Hey, that's a slam dunk. We want to make more food in the same space. And it works because efficient equipment puts more energy into the food you're cooking. You get these ancillary savings that we talked about a little bit, like fewer people can do more with programmable self-cleaning equipment. You also are saving water and sewer costs, which is a big deal. If you had fryers in your kitchen, some of you may have fryers in your kitchen, then you'll save a huge amount of oil, which is the #1 cost for running a fryer. And then also you can reduce food waste. All big sustainability, but also practical operational goals. The next thing is that high efficiency equipment tends to be better quality equipment, and so you get a better life cycle out of it, right? I just want to urge everybody, don't let folks come in and value engineer out your really nice equipment. That's the first thing that tends to go, because people don't understand all of these benefits of the energy efficient equipment. It is super important. That's the engine of your kitchen. Don't value engineer out your engine, right? And then the final thing is you get more comfort if you have the highly efficient, well-designed kitchen. That kitchen is going to be produce lower radiant heat. It's going to be a lower temperature for the workers. And I just want to give you a heads up that in California, we're about to have a law on the books, Cal OSHA, a heat illness law that will cover commercial kitchens, and it will mean we can no longer take a human being and throw them into a 100-degree kitchen and subject them to that kind of heat. This law will now protect people. Now, university kitchens tend to be better than the local mom and pop pizza joint, but heads up, that's in California. It will probably spread out to the US. And having worked the broiler in Memphis, Tennessee, in 110-degree, 120-degree heat there, I'm all down with this. I want kitchens to be more comfortable. Now, in most higher education, if you have goals, or if you're already starting to look at the notion of decarbonization, which ultimately kind of leads towards electrification, you have 3 pathways. You're going to have a lot of existing buildings, and the biggest challenge for moving towards your all-electric kitchen in your existing building is limited electrical panel size. And I think some folks have talked about that when yesterday we were talking about electric vehicles, right? Electric vehicle fleets and the limitations of panel size. So you're going to get into existing buildings with limited electric panels, and then you're going to have another course of buildings which are going to be existing buildings, but they have enough panel capacity. You may have a building that was over designed, or maybe you have a building and you went through and did a bunch of energy efficiency work, lighting, HVAC, and you've ended up with some extra panel size. Those are rarer, but they do exist, and you may find those on college campuses. And then, of course, the easy one is new kitchens and major rehabilitations, right? So totally new construction. So when you get into those kitchens that have limited electric panel size, you replace the gas and electric equipment with high efficiency gas and electric equipment, okay? So if you have an old refrigerator, replace that old refrigerator with the Energy Star rebated, high efficiency refrigeration system. If you have old convection ovens in there, and we actually did a study with the California Energy Commission where we went into the UC Medical's facility up in San Francisco, so UCSF, and replaced the old convection ovens with high efficiency natural gas convection ovens, and we cut the carbon in half, we cut the energy use in half. So in those existing buildings, high efficiency gas appliances will cut carbon right now. It is a very straightforward fix that actually pays for itself. And I'm just a cold hard engineer. I'm all about cutting carbon. Remember, I want to cut carbon as fast as possible in every way possible. So I would much rather have you go in and put in a high efficiency gas appliance than sit back and wait 5 years to try and figure out your electrical problem so that you can put in the electric oven, okay? I want the carbon reduction right now. This should be the golden decade of high efficiency gas appliances. That buys us sort of a decade to work out our electrical infrastructure and start to move forward, right? So just very practical stuff. In those existing kitchens with electric panel capacity, you can replace your gas and electric with your all electric, no problem. That's all very doable. And then in the new kitchens, of course, that one becomes easy. You can build the electrical infrastructure. You have no problem doing your all-electric kitchen there. I want to give you a couple of photographs. These are some shots from a high-tech campus down in Silicon Valley. These are all-electric kitchens, and what you see there are some combination ovens, which are programmable self-cleaning ovens. They save a huge amount of labor. They are incredibly flexible. You can cook an entire menu out of the combination ovens, and they're highly energy efficient. And then next to those, you see some induction cooktops, some full-size induction cooktops that are meant for commercial food service. They are light, they are very flexible, they perform amazingly well, they perform better than the traditional cooktops. So a killer technology, the induction cooktops are killer app. Down there towards, and the picture on your right that's down towards the right, you'll also see an induction griddle. And for people that want to try and mimic a broiler, you can take those griddles and actually cut grooves in them if you so desire. Personally, I think it's fine to cook your burgers on a griddle. That's what In-N-Out does, and all of the people in California here, we're all addicted to In-N-Out. So then I've got another set of photos here. This is sort of a fast cook line, cook to order line. You see I've got a couple electric fryers. Same thing, I've got one of those induction griddles with the grooves in it. I have an induction cooktop. I'm also showing you a couple of these little induction soup warmers. They are really amazing. They cut the energy by about 2/3, and because they have some smart controls in them that vary the heat depending on how much food is in there, you also get better food quality and less food waste. You're not throwing away the bottom of the barrel soup or the bottom of the oatmeal because it got all dried out. And then down there in the lower right-hand corner, you see mini combination ovens, and these things are the killer apps. These mini combination ovens are Swiss Army knives. They're programmable. You can use them to program each shelf, put things in and out. Really stunning technology, right? Here's another photograph of something that might be a little closer to your university kitchen. Same thing, I've got a couple of combination ovens there. I've got a really high efficiency griddle. I've got a small induction cooktop, and I've got some high efficiency refrigeration. And the other cool thing about this cook line is that because I've got all the electric equipment, I've got the electric griddle and the electric induction, I can set them on a refrigerated base. So from a labor standpoint, all I have to do is reach down and pull open the drawer to get to the food that I can then cook, right? So this reduces steps, makes my kitchen that much more effective. And finally, the killer app, the thing that people are really, really, truly worried about in most institutional kitchens is how do we do wok cooking? If we want to do Asian food, how do we do it right? Are there induction woks? And yes, there are. Now, admittedly, the supply is limited in the US. They've been using induction woks in Asia for decades, so this is not a new technology. There are multiple manufacturers that are now working to bring these into the US. yes. What I'm showing in this photo, these are the photos of the induction woks that they used at the Microsoft campus up in Seattle. It's a brand new thing. If you go out and Google that, you'll see article after article about how they developed this wok, tuned it up. It's a pretty amazing technology. Okay, so I've shown you what you can do. It's all practical, it's all doable. How do you do this on your campus? What resources are available for you? And I want to start with a website. This is the California Energy Wise program, caenergywise.com. Now, I'm here representing the California clients, the University of California, the CSUs, because they are our utility customers. But if you're outside California, these resources apply to you as well. There's plenty of stuff that you can use that will help you out. And we want everybody to decarbonize across the country. So, caenergywise.com, remember that website. If you go there, you will see a whole list of things that are offered, particularly to California customers. We can do energy surveys, send somebody out to your campus, work with you. We can do design consultations. And then there's all the rebates, and then we also have Try Before You Buy program where you come in and work with our consulting chefs. And in California, we have Try Before You Buy energy centers. In LA, there's 2 down there, SoCal Gas, SoCal Edison, and then up north, PG&E, which is our center. We all have the capability to work with you to get your hands on equipment. Other things that are just resources, information resources, we have a whole set of design guides on kitchen ventilation, on hot water generation. Remember I talked about heat pump water heaters? Read those design guides. We also do seminars. The seminars are no cost. You can actually go back and watch the seminars after the fact. We put the handouts up there. If you are a food service consultant, you can get CEUs for watching those seminars. And we also have return on investment calculators that anybody can use. They're very simple calculators, and use those to talk to the purchasing agent so you don't get your beautiful equipment value engineered out. All you have to do is sit down and plug in the equipment that you're looking for. The numbers pop up, and once people see the numbers, there's no way they're going to value engineer out your equipment, because efficient equipment pays for itself. Typically, over the lifespan of that equipment, the energy savings pay for the entire piece of equipment. But you need to do that ROI to know that. So all great resources, caenergywise.com. And then the biggest resource, the thing that is most exciting to me, is that we now have what we call instant rebates. And once again, I'm here to talk about the California instant rebates, but there are instant rebates in other states, and I will show you that map. But the instant rebates are a way to change behavior, and they're very, very simple. All you have to do is find a participating dealer, which we work with the dealers to get everybody hooked up, purchase a qualifying product. There are thousands of pieces of qualifying equipment on our qualifying products list. I'm going to show you how to get to that. And then you get the instant rebate, and the instant rebate is taken off right on the invoice. So you buy the piece of equipment, and the discount is right there. No paperwork, no nothing, which works particularly well for the complex purchasing at higher efficiency, higher education, facilities. And also that means that the funds, the savings go right to the food service side. It doesn't go into a general fund somewhere. So very, very easy to do. And if you want to look at that qualifying products list, it is on the website. It's an Excel spreadsheet. And if you are not in a place where you can get these rebates, you should still use this sheet as your spec sheet, okay? So when you are speccing out your equipment, what you want to say to the contractor, the food service consultant, the dealer, whoever you're purchasing your equipment from, you want to spec in, oven shall be of the level of California instant rebates qualified, right? That will guarantee that your equipment won't get value engineered out, and you will get those savings. Now, if you're in a place where the rebates are available, we have, rebates across the board, gas and electric equipment and dual fuel equipment, and the rebate numbers are very, very high. I've been talking a lot about convection ovens. Our convection oven rebate is $700 per cavity, okay? Those are really, really juicy rebates. Do not walk around that. They're easy to get. All you have to do is buy a high efficiency piece of equipment, and for university, you typically have the capability to buy better equipment. Typically what we see is that people try to spec the right thing, they try to spec the high efficiency equipment, and it gets blown out on the back end, it gets value engineered out. Somebody takes their eye off the ball. These rebates are meant to keep the eye on the ball, okay? So not just in California, but Nevada, Washington, Michigan, Indiana, North Carolina, South Carolina, New York, Massachusetts, Rhode Island, New Hampshire, also in Pennsylvania. We're about to roll out a big program in Illinois. There are rebates all around the United States. And if you're not in this instant rebate program, I urge you to still call your utility and see if there are rebates. I know that we're working on a rebate program down in Texas. I know that there are a bunch of rebates up in Oregon. Call your utility and talk. But if you're in one of these states, you can get the instant rebate, which is the thing that we really care about the most. We want you to get that money. It's your money. We're trying to get you back your own money. And this is a money slide right here, speaking of money. If you have questions, regardless of where you are, who you are, you can call this number, you can email these folks. The people who implement the Instant Rebates program is a company called Energy Solutions. We partner with them. Our facility is sort of the brain trust. The Energy Solutions people are the implementers. If you call the number, if you email them, there's somebody right there. They will answer back fast. Their job is to connect the dots and make these things happen. So a lot of resources. And with that, I will say thanks. You have my email address here if you need to contact me. And we have a slim crowd. I'll ask if there's any questions in the crowd here today. And everybody's smiling because we're right before a break too, and I'm right at time. So why don't we call this? Once again, thanks for the folks in the room who got up and came. Thanks for the folks watching online. Oh yes, we do have one question.
So with obviously the demand energy, we use that on hoods and stuff like that.
Mm-hmm.
Doing it in the kitchen makes all kinds of sense. What about energy recovery? Because we're exhausting a lot of hot air out there. I know grease is an issue, but is there anything being done to recover all the heat that we're blowing out of the building?
So this is a great question. Yeah, so the question is, how do we try to grab some of that heat coming off the appliances and going up the exhaust hood? Essentially, is there an off-the-shelf energy recovery technology that will grab that heat and put it back into either our hot water or our space or something like that? And while people have dabbled in that, and there have been a few systems out to try and grab that heat, it's typically very difficult to get much energy back out of that waste stream because it's moving through the hood filters pretty quickly. And it turns out that waste heat is a lower temperature than you think it is. I may have a 350 degree griddle down here, but the air moving up through the hood is running around 150 degrees. So it's a challenging waste stream. But here's the good news. The thing to do is just to keep the heat out of the airstream to begin with, and you do that by using high efficiency appliances. So if we go from that traditional monolithic kitchen with a bunch of open heat sources and a lot of radiant heat to something that's our kitchen of the future with more ovens, the combination ovens and high-tech tilting skillets and things like that, then we're just producing less heat, so you don't need the heat recovery. But that's a great question. I appreciate it. So anyway, I will say goodbye to everybody. Thank you so much. I think it's break time. And once again, thanks to the Influence Group for having me here today.